Hello, everybody. So this unit circle is available to you. It's underneath the modules and Canvas, and it's a really nice, clean, crisp picture of the unit circle with the special angles 30, 45, 60, etc. These are all just special angles. They don't comprise all the angles on the unit circle. We all know that the cosine of any angle is the x value to where that angle meets. The sine is the y value to where that angle is. But the red boxes, they all represent the tangents of those angles. So remember, tangent is y over x. So just very quickly, if you have the tangent of, let's say, 5 pi over 6, you have to first realize that tangent is y over x, and then locate 5 pi over 6, which is right there. The y value is 1/2. The x value is negative rad 3 over 2. So you have a positive divided by a negative, so that means the whole thing is negative. And when you divide this out, you're dividing by a fraction, so you can flip and multiply. You can you're flipping the divisor and changing it to multiplication. The 2's cancel out, leaving you with negative 1 over rad 3. And then if you rationalize the denominator, so multiply by rad 3 over rad 3, you eventually get negative rad 3 over 3. So the red boxes are designed to save you some time. If you can commit them to memory, they all represent the tangents. Tangent is y divided by x. But where have you seen that before? Where have you seen y divided by x? Hopefully you're thinking the slope. The slope of a line is the change in y over the change in x. Well, watch this. This 5 pi over 6 has a tangent of negative rad 3 over 2. If you continue down that line, you reach another angle that also has a tangent of negative rad 3 over 3, because it is the slope of that line. And this line has one slope. It happens to be rad 3. This line has a slope of 1. So this angle has a tangent of 1, and this angle has a tangent of 1. So that's another thing that might prove to be helpful. So today, before you do the homework, there is homework on Delta Math. Before you do that homework, spend 10 minutes on that unit circle game that's on the module. Spend 10 minutes trying to fill in the unit circle accurately in less than 3 minutes. And then spend another 10 minutes on that second link for the trig function. So today we're going to talk about something called coterminal. Co means with, terminal means stop. So negative 300 degrees, negative 300 degrees. A negative means you go clockwise. So here's negative 90, here's negative 180, negative 270, negative 300 is about right there. Is there another angle that stops right here? Is there another angle that stops, terminates with negative 300? And yes, there is. It is this positive angle. So to find any coterminal angle, all you have to do is add or subtract an entire circle. Just add or subtract a whole circle. So let's just generate many coterminal angles right here. Negative 300 degrees. It is coterminal with 60 degrees. All I did was just add 360. It's not the same thing as 60 degrees. Don't write that, don't think it, don't say it. It's coterminal. It stops at the same spot. And if you add 360 again, you would get, this is 420. If you add 360 again, you get 780. And you could keep on adding and adding 360. You could also subtract 360. Subtracting 360 from here gives you negative 660. So needless to say, there are an infinite amount of angles that are coterminal to each other. You just add or subtract 360. So for here, 670 minus 360 is 310. If you subtract 360 again, you get negative 50. If I added 360 to the original, if I add 360 to this, I would get 970 plus 60 is 1,030. What about 4 pi over 3, 14 pi over 3, 3 pi over 5, etc.? It's the exact same concept, but here we're in radians. So you have to just add or subtract 2 pi. 2 pi is a whole circle. And since this divisor of 14 pi over 3, since that's being divided by 3, I want to do myself a favor and convert 2 pi to something over 3. So what would I do? I would add or subtract 6 pi over 3. Isn't 6 pi over 3 equal to 2 pi? So if I add 6 pi over 3, I get 20 pi over 3. And these two angles, this angle and this angle, they're not the same, but they stop at the same spot. They stop at the same spot. And I could keep on going, 26 pi over 3, or you could minus 6 pi over 3. You're going to get very, very good with fractions. Now, what would I add or subtract here? I mean, I know you're adding or subtracting a full circle, but a full circle in radians is 2 pi. So what fraction am I thinking about for this? Thinking about 10 pi over 3. Or 5. 10 pi over 5. 10 pi over 5. So if I add 10 pi over 5, I get 7 pi over 5. And then 17 pi over 5, etc. I could subtract 10 pi over 5, so that's negative 13 pi over 5. So adding or subtracting a full circle will get you a different angle, but that angle will be coterminal. It'll stop at the same spot. And then one last thing, converting from radians to degrees. Okay, so this is in radians. How many degrees is this? Well, we have to remember that pi radians is 180 degrees. So I can just convert this right away and replace pi with 180 degrees, and I discover that that's 18 degrees. So pi over 10 is 18 degrees. Same thing here. I can take 5 times 180 degrees over 3, and this is 300 degrees. But what do I do here? There's no pi. So how do I convert that to degrees? I can go back to this sentence right here. If I got an equal sign here, I know that pi is 180 degrees. So I can divide both sides by pi. Nothing stopping me there. And on the right side, you have 1. 1 what? 1 radian. On the right side, I've got 180 over pi degrees. So 1 radian is equal to 180 over pi degrees. How does that help you? Well, this is 7 radians. If 1 radian is 180 over pi degrees, then certainly 7 radians is just 7 of these. So 7 radians is 7 times 180 degrees over pi. And I need my calculator for this one. 7 times 180 is, was that 1260? Let's double check. Oh yeah, 1260 degrees over pi, which is about 401 degrees. What about converting to radians from degrees? Well, 45 degrees, let's look, this is pi radians. To get half of a circle, it's pi radians. So halfway there is pi over 2 radians. And half of that is pi over 4 radians. So 45 degrees is pi over 4. 160 degrees. 160 degrees is not a special angle. So let's go back to what we know. I know that pi radians is 180 degrees. And I want to know, what is 160 degrees? Well, I got an equation. Now I'm going to divide by 180. What does that do? Well, on the left, you've got pi over 180. Radians, radians, radians. On the right, you've got 1 degree. So 1 degree is equal to pi over 180 radians. So that means that, 160 degrees must be 160 of those. And that's exactly what I do. So I can convert this. I should be using this. So 160 times pi over 180. And then simplify. 160 is 10 times 16. 180 is 10 times 18. So the 10s cancel out. 16 and 18 both have a 2 in common. So I have 8 pi over 9. And then negative 30 degrees, well, 30 degrees is pi over 6. So negative 30 degrees is negative pi over 6. This is from knowing this is knowing your unit circle. But if you, another way to do it is to go back to this equation. 1 degree is pi over 180 radians. So negative 30 degrees must be negative 30 pi over 180s. And the pi and 30 over 180 simplifies to pi over 6.